Well, hi everybody. This is my newest project here based on a decoder to signal converter. What I have basically done is used a output from a conventional 4-channel decoder like the stationary decoders that you get on the market. I personally model Merklin equipment. So I mean, this is something that I've been owning for the past 30 years. Works great, doesn't have any problems. Everything has been working so far. This is actually my test rig. Got a standard Merklin keyboard, a Merklin central unit, and then the Control 80, which I use normally as a setup in my programmer for coding the locomotives that I have. So what I decided was, instead of buying and investing in a whole bunch of new stationary decoders, probably just why don't I just kind of rig up some circuit, because I'm an engineer and like to tinker around with a lot of electronics for model railways. So I came up with this idea of duplicating the outputs of a standard decoder and then pass it on to a circuit that I devised here using a standard impulse relays, or what you would call typically as bistable relays. I picked up a whole bunch of them, almost like about 50-60 of them off eBay from somebody who was selling it. I think a lot of these relays are also available. So in principle, the circuit is pretty simple, and this is a board that I actually designed at home. So it's basically 4 channels, accepts the inputs from the decoder itself, and then the relay actually pulses the signals as you see out here. And these are all homemade signals, because I do not believe in investing a whole lot of money in buying commercial signals when I have the infrastructure to make these at home. And I'm just going to kind of flip over this circuit board to show you what actually it is. It's pretty simple circuit and I designed the PCB at home. So this is the PCB that I actually just kind of etched at home. I typically use pad-to-pad as a software for designing a circuit, and I kind of build all the 4 channels. So this module actually goes below my layout and then get hardwired based on also, I mean, I kind of have these terminal outputs, and the relays are pretty strong. I mean, they can drive almost up to like 1 ampere load at any given time. So, but I would prefer just kind of driving just a set of LED signals. So if that kind of makes sense, to keep the total consumption of power and the current to maybe about under 30 milliamperes. The board in operation. It's connected to 2 sets of signals. I've got 2 more channels that are free that I'll probably be using it at a later given time. So it actually takes the input from my decoder and converts it into a visible signal output. So over here, I've actually just switched off some of the external lights to my man cave over here, where I have my workshop, just to make sure clear in the video over here how the signal lights actually operate. The Atlas switch that I've got here is just kind of temporary for this demonstration. I mean, it has a tendency to spring back after I operate the control. But in principle, what I wanted to kind of show you is, right now it is set to the diverging points out here that the train's going to be leaving to your right hand side. As you can see that the signal is set to the points being thrown, and what I'm going to do actually is I'm going to change that, and as you see that now the points have been set straight. I know that there's this kind of space out here. They don't work very well. I mean, these are not my favorite points. I do model Fleischmann track on all of my layout, but in reality, if you can see that the signal, the diverging points and the signal is now switched off. It's now pointing to the track right of way straight up. and I've also changed the points on the other one, assuming that the second set of signals, if you can see on the right hand side, is set for like shunting operations or something of that nature. Or you can actually, I've got another set of relay sets or circuits that I've designed for automatic signal control. As the train passes over a reed switch, then it kind of sets it to either have the track be clear, or maybe the track is set to a warning. Like I'm actually not changing this, I'm just controlling the signal on the right hand side. As you can see, I can set independent points on the signal, so I could have that guy. And then this one again, I can set, okay, it is set, but if you just saw it momentarily that it had a tendency of kind of springing back, it's because this switch motor is not really very good. I mean, the Fleischmann has a cutout that's already built into the point motor itself, so the tendency to slip back doesn't occur in that case. So that's principally, I mean, what I've got, how this circuit works. Again, you can use any standard decoder that's available on the market. It doesn't have to be, you don't have to go and buy a separate set of decoders to kind of run your stuff. I just don't believe in spending that kind of money, just buying stationary decoders for operating signals, when a simple circuit like this can actually do the trick.